Okay, so we go to question 4, question 2, Roman numeral 4. Okay, so this is the question that we'll start with. This one, the distance between CD. Now, how do you find the distance between C and D? So let me just write the coordinates of C. Okay, so coordinate C here. Okay, we have 2 comma negative 3, 2, okay, comma negative 3. D, we have negative 4 comma 5, negative 4 comma 5. Okay, so these are the coordinates that we have. So from there, how do you find the distance? So for us to find the distance, we use the formula for the distance given the coordinates. So it can be the length of the segment, it's the one that you can use, or the length of CD. So the length of CD, so length of CD, okay, is equals to the root, okay, is equals to the root of x2 minus x1. We introduce the parentheses there squared plus y2 minus y1, okay, in the parentheses there, then you square it. Okay, so from there, this is the formula that we are going to use. So the length of CD, okay, let me just name this. Okay, so we use a different, okay, so this is x1 and that is y1. This is x2 and that is y2. Okay, so from there, the length of CD, so the length or distance CD is equals to the root, okay, is equals to the root. What is our x2? Our x2 we have is negative 4. So to be negative 4, okay, negative 4 minus, what is x1? X1 we have 2, okay, this has to be in the parentheses there, you square it, plus, open parenthesis, okay, what is our y2? Our y2 is 5 minus, what is our y1? That is negative 3, okay, squared. That is what we have there. So the length of CD equals to the root, okay, so what is negative 4 minus 2? That is negative 6, okay, negative 6 in the parentheses squared plus, what is 5 minus 3? That is 8, because if you have a negative multiplies, you have a positive there, so it will be 5 plus 3, that is 8, okay, squared. Okay, so from there, the length of CD equals to the root, what is negative 6 squared in the parentheses? That is 36, okay, plus 8 squared, that is 64. So it will be the length of CD equals to, what is 36 plus 64? That is the root of 100. Okay, so we're going to have 100 there. So the length of CD, the square root of 100 is 10. And do we have any units here? Oh, a sensor moves from point C 2 comma negative 3 to D negative 4 comma, determine we don't have any units, so we put 10 units. Okay, so this was our length of what? CD, or let me say distance CD. This is what we this is what we had. Okay, so let's proceed to question B. Question B, the question reads, show that the given lines y equals to negative 3x plus 2y and y equals to 13x minus 4y are perpendicular. So perpendicular lines satisfies this equation, m1 m2 equals to negative 1. So remember the line of the equation, it can be found using this formula, y equals to mx plus c, where m represents the gradient. So m, it is representing the gradient there, okay, and c is the constant. So in this case, we are only interested in us knowing the gradient for these two equations that we have. So the first equation that we have, let's try to find the gradient for the first equation and the gradient for the second equation. Then from there, we'll substitute into this equation for us to come up with a perpendicular, for us to come up with if these two equations satisfies, I mean, if these two equations, equation 1 and equation 2 satisfies what? Satisfies this formula for us to come up with a perpendicular line. Okay, so now we have this. So now what is the first equation that we have? We have y. Okay, y equals to negative 3x plus 2y. Okay, let's find the gradient for this. We have y and y, we collect like terms there, so to be y minus 2y equals to negative 3x. Okay, equals to negative 3x. From there, what is y minus 2y? That is negative y. Okay, so we're going to have negative y equals to negative 3x. So we divide throughout by negative 1 because we're only interested for us to have the y there. So it will be y equals to 3x, because negative and negative will disappear. So this is the first equation that we have. The first equation that we have, y is equals to 3x. And looking at this equation for us to find looking at the equation of a straight line, we have y is equals to mx plus c. So y equals to mx plus c. So meaning our constant here, it was 0. So m there represents the gradient, and m here, it represents the gradient. And when we come to our equation here, the m there, 3 is in the position of m. Therefore, m is equals to what? 3. So 3 is our gradient in this equation. So this is m1. Okay, so this is equation 1. We go to equation 2. Equation 2, what do we have there? Equation 2, we have y is equals to 13x. So we have y equals to 13x minus 4y. Okay, let's collect like terms. So to be y plus 4y plus 4y equals to 13x. Okay, so from there, to be, what is y plus 4y? That is 5y equals to 13x. So we divide throughout by 5, also here by 5. Okay, so we cancel 5 and 5 disappears. So we're going to have y equals to 13 over 5x. Okay, therefore our m2 is equals to 13 over 5. Okay, now if our m2 is equals to 13 over 5, let's try to substitute into this equation here to see if we are going to have if m1 m2 is equals to negative 1, because this is the equation that can help us prove to say if these two equations are what? Perpendicular. If these two lines are perpendicular to each other. So our m1 is what? Our m1 is 3. So our m1 is 3. We multiply it by our m2 is what? 13 over 5. So what is 3 by 13? That is 3 times 1, and we have 3. 3 by 3, we'll have 9. So it will be 39 over 5. And 39 over 5 is not equal to what? Is not equal to negative 1. Therefore, m1, therefore, these two equations that we have are not perpendicular to each other. So you say therefore, okay, y equals to negative 3x plus 2y is not perpendicular. Is not perpendicular. Okay, is not perpendicular to what? Is not perpendicular to y is equals to negative 3x plus 2y is not perpendicular to y equals to 13x minus 4y. Okay, so meaning, because the question was saying that prove, okay, we're supposed to come up with a proof that shows, okay, show that the line given is line y equals to negative 3x plus 2y and y equals to 13x minus 4y are perpendicular. So they're not perpendicular to each other. Okay, because they're not satisfying this equation here. Okay, so they're not perpendicular to each other. Okay, so that was question B. Okay, 2B. Okay, so we move to question